Bismillahirrahmanirrahim. My name is Dr. Muhammad Hanif. Today I am going to present you the paper A Novel and Efficient 3D Multiple Images Encryption Scheme based on chaotic system and swapping operations. The agenda of this presentation is, first of all, we will go through the introduction, then the problem statement, some research questions, then literature review, validation matrix, conclusion, references, and then in next video I will show you the code and the simulation of this paper. First of all, introduction. If we look to this modern age, we can see images all around us. There are images, social images, medical images, military images, satellite images, commercial images, to name a few. And sometimes these images happen to be very sensitive. For example, a blueprint of a new car or some blueprints of a missile technology, for example. So to store such kind of images on some storage device or transmitting these images openly on some open network is quite threatening. So the security and privacy are the two main concern of every person. Protection of any kind of data, as we are talking about the images from unauthorized access, is main focus of this modern era. Traditionally, these images are converted into some noisy form so that they may not be recognized by the potential antagonist upon accessing them. It means that we are encrypting these images at the source side. So if we are talking about the images, so we have grayscale images and color images. There are some existing encryption schemes for these images. They are single image encryption schemes and multiple images encryption schemes. In the literature, you can easily find a single image encryption scheme and multiple images encryption scheme. The basic operation that are performed in the encryption scheme are called confusion and diffusion. The confusion is also called scrambling or transposition or permutation, while the diffusion is called substitution. For these operation, confusion and diffusion, few techniques are used. They are called chaotic maps, cellular automata, DNA computing, circular shift operation, block transform, etc. So these are the different techniques used by different researchers to perform the above mentioned encryption schemes operations to do the confusion and diffusion. In this paper, we will also use a particular technique to perform these confusion and diffusion operations. So the current image encryption scheme are composed of that each encryption scheme must have an encryption algorithm and its decryption algorithm. Key for the encryption and decryption algorithms: chaotic systems, encoding scheme, confusion and diffusion operations. Problem statement is already mentioned in the introduction that we can see images all around us. For example, there are social images, medical images, military images, satellite images, commercial images, to name a few. And as already previously mentioned, that sometimes these images happen to be very sensitive. For example, a blueprint of a new car, or a blueprint of some missile technology, or a blueprint of some secret place. So to store such kind of images on storage device openly, or transmitting these images through open network, is quite threatening. So one has to encrypt more than one images in one go, as we can see multiple images all around us. So encrypting a single image and then encrypting one by one is very time consuming. Thus we need an encryption scheme that can encrypt multiple images at a time, or multiple images in one go. So there is a dire need of encryption. There is a dire need to encrypt more than one images in one go. In this study, we will venture to develop the multiple images encryption scheme, which will be secure, time efficient, and will be very beneficial for interactive setting in real-time environment. Research question. The following research questions will be focused. How to develop a new multiple images encryption scheme using chaotic system. How to develop more secure and more time efficient multiple images encryption scheme. How to compare the validation metric and particular encryption throughput for our scheme to demonstrate the superiority of our over other existing multiple images encryption schemes. The research objectives. The following are the research objectives. Developing a novel and efficient multiple images encryption scheme based on chaotic system and circular shift operation. Developing a novel and efficient multiple grayscale images encryption scheme based on chaotic system and swapping operations. So these both are different two research papers. And one research paper is developed for multiple color images encryption scheme, which is based on circular shift operation, while the other research paper is based for multiple grayscale images using the chaotic system and swapping operations. Developing the above mentioned multiple images encryption algorithm with relatively better validation metric and particular large key space, rich plain text sensitivity and time efficiency. So the validation metric for image cryptography are the first one is key space, then key sensitivity, plain text sensitivity, information entropy, NPCR, UACI, histogram, variance, correlation coefficient, PSNR, noise and data loss analysis, and time complexity analysis. These are the validation metrics which are covered in this research paper to compare our result with the existing literature. Literature review. In the literature review, you can easily find grayscale images, color images, which are RGB, red, green, blue, single image encryption scheme, and multiple images encryption schemes. In the literature, you can easily find the literature for such categories. So this is the overview of the literature review. You can study by yourself. So now we are starting our paper, a novel and efficient 3D multiple images encryption scheme based on chaotic system and swapping operations. In preliminaries, we will focus on the 3D formation, that how multiple images are converted into 3D format. Then we will study about the chaotic maps. Then we will study about the swapping operation. In the encryption scheme, we will study the encryption procedure, then the decryption procedure, and in the security analysis, we will study about the validation metric. So these are the basis of this paper which we will study. Preliminary, as we are talking about the preliminary, there are three subparts in the preliminaries. The first one is 3D formation, then the chaotic maps, and then the swapping operation. So first one is grayscale images are input in such a fashion to form a 3D image. A pile of 3D image is formed. How this pile is formed? So the first image, the multiple images with the same resolution. Each and every image must have the same resolution, mean that their dimension must be same. So these grayscale images are put over one another. These multiple images are put over one another to form a 3D pile. Then the chaotic map. Two chaotic maps are used in this research. The first one is called intertwining logistic map, which is shortly abbreviated as ITLM, and the second one is called improved piecewise linear chaotic map, which is shortly abbreviated as MPWLCM. Then the swapping operation, row wise swapping and column wise swapping operation are performed in this particular research. Then the encryption procedure, and then this is the simple form of the encryption procedure. There are multiple phases, total 5 phases, and first phase, the multiple images are converted into a 3D format. So as you can see that we have n multiple images, they are converted into a 3D file, mean that these images are put over one another to form this 3D image. Then in second phase, the SHA-256 hash value of this 3D image uh, is derived, and which is used for updating the initial value and system value parameters based on the SHA-256 hash value and the user input key value. So these are the basic initial values which will update the initial value and system parameters of these two chaotic map, which are intertwining logistic map and piecewise improved piecewise linear chaotic map. Here the initial value and system parameters are updated. The basic reason of this SHA-256 hash value is to obtain the plain text sensitivity. The plain text sensitivity mean that each time if there is a minute change in this image, a different initial value and system parameters will be obtained, and thus the pattern of these chaotic map will be different each time. Then in phase 3, the intertwining logistic map generate 3 chaotic streams. The first one is used for the images selection. 2 different images will be selected using this chaotic stream. Then the row selection, 2 different rows will be selected using this chaotic stream, and for column selection, the 2 different columns value will be selected from using this chaotic stream. And the third one is improved piecewise linear chaotic map, which is used for the key image, which is used for the diffusion process. And phase 4, 2 different images are selected from this file, this 3D image, for example image number 5 and image number 18. So these are the 2 different images based on the this image selection key stream, chaotic stream. Then from these 2 images, 2 different rows will be obtained, one from one image and the other is from other image, and these both rows are then swapped, and the same process is performed over the column. One column from one image and other column from other image, both the columns are then swapped, and to obtain the scrambled 3D image. Then over this scrambled image, the XOR operation is performed in phase 5 based on key image key stream, and thus the final 3D encrypted image is obtained. So this is the encryption procedure. The exact reverse process of this particular procedure is performed in the decryption process. In the decryption process, in phase 1, we have the 3D encrypted image. Then the key is used to obtain the initial value and system parameters of these 2 chaotic maps. As you can see in the previous image, that in the last phase the XOR operation is performed, which is between the 3D encrypted image and the key stream. So here the same process is performed. The XOR operation is performed between the key image key stream and the 3D image to obtain the 3D scrambled image. And then the row selection and column selection is performed toward those selected images, which is repeated iterative number of times to obtain the particular 3D image, and then the 3D image is split into their particular number of images. So these are the encryption and decryption procedure. So you can see from the result that we have currently 4 images. These 4 images are put over the top of one another, and then the scrambled image which is shown in the B, and then the encrypted image which is shown in the C, and then the decrypted image which is shown in the D for these 4 images. The same process is performed over the 9 different images. So we can see that we have 9 different images. These 9 images are put over the top of one another, and then we have the scrambled image and then the encrypted image, and then the decrypted image. So from the decrypted image and the input image, you can see that they both are identically the same, so no loss in the decrypted images occurred. Security analysis, as we already mentioned previously, that we will cover these validation matrix. First of all is key space analysis, or key space analysis, which is equal to 1.157 into 10 raised to the power 203, which is far more than the other recently encryption scheme. So we can see that our encryption scheme can resist toward the brute force attack, that we have large key space. Then the key sensitivity mean that if a single bit change is occurred in the key, then the result will be different. For example, we have 9 images as shown in image A. Using a particular key, these 9 images are encrypted into this format, which is called B. And then a particular single bit change is occurred in the key, and then with that different key, again these images are converted, and we obtained the other encrypted image called C. So these both encrypted images are from the result of 2 different keys, and both keys are different from each other very minutely, a single bit. So if we differentiate these 2 images from one another, then we obtain the image D. Image D is obtained. So if we decrypt that particular image B with its original key, the result is shown in E. But if we decrypt the encrypted image B with the other key, which is of the key of the E, then the result is not fine, as you can see from the image F. The same process is performed over the encrypted image C. If we decrypt the image C into with its original key, then the result is shown with image G. But if we decrypt the image C with the key of image B, then the result is very different. So it means that our proposed encryption scheme is best against any kind of key attack. If there is a minute change in the key, then the decryption result will be not desirable. So this table also represents the key sensitivity analysis, that if there is a minute change in the key, and that minute change is represented through this delta. Delta is 10 raised to the power minus 14. 10 raised to the power minus 14. So if we made 10 raised to the power minus 14, which is a very minute value, which is a very small value, if we made such kind of change in the key, then the result will be different, and the entire result will be different, as the average overall average show 99.0924. this much the result will be different if we do this much less change in our key. Histogram analysis. Image A show the histogram of the original images. As you can see that they are not smooth, and but if you can see in the image B that the result of these images are, the encrypted images are very smooth. This is the histogram analysis. Correlation coefficient. The correlation coefficient shows that the pixels with the same correlation fall in a particular plot. So the ABC show the correlation coefficient analysis for the plain images, and the DEF show the correlation coefficient for the encrypted images. So from the result you can see in the DEF that the pixels are not identical anymore. So these are the result, or result are far better than the other particular researches. Then the information entropy of all results shows that they are far better for both the encrypted images and multiple images are far better than the other encryption schemes. So you can see that these value or obtained value are very close to the desirable value, which is 8. NPCR and UACI values, these are represented and the percentage 99% and 33%. So you can see that our results are far better than the other encryption scheme for NPCR and UACI. Peak signal to noise ratio. The peak signal to noise ratio represents that what is the main difference between the original image and the decrypted image, and the original image and the cipher image. So that you can see that the difference between the original image and decrypted image are same. Both the decrypted image and the original image are same with no loss, and the original image and the cipher image are far different from one another. Noise analysis. During the transmission some extra noise can be added. So if we add some extra noise to our plain images or cipher images, the result shows that the decrypted images are still visible. Data loss analysis. 25%, 50% and 75% data loss, but the result is very clear and the decrypted image is still visible. Time complexity. The time complexity shows that the encryption and decryption process time. So the encryption and decryption process time in seconds are far less than other encryption schemes. So our encryption scheme has far better time execution than the other encryption schemes. Throughput analysis. The throughput analysis shows that our image encryption scheme with the average of 1.531 Mbps is far better than some other images encryption scheme. So the encryption throughput is also better. So this is a particular image encryption scheme, multiple images encryption scheme based on 3D space and using the two chaotic system called the intertwining logistic map and improved piecewise chaotic map with swapping operations both over rows and columns, and the result shows that our obtained results are far better than the other encryption schemes. These are the references. Thank you so much. If you have any question you can ask. After this I will show you the particular execution of this particular research using MATLAB in the next video. Thank you so much.